All right, I want to incorporate a engine so we can kind of decouple a few things. Right now we have our tick, basically our update and render is one thing. We're kind of doing a bit would be kind of cluttering this up if we try to expand on this current demo here. So one thing I'm thinking is we'll create the engine class. So one thing I want to do here, let's take the render system. Let's make it take width, height, and we'll come back into the main here and we're going to move some stuff. So we'll take all of this, right here, and we'll cut it out. Put that there, and then we'll put these there. And when we come back into our rendering system, right here above that, and then we can derive that DRP. Did I leave that here? We can put that in our rendering system here. And then that should clean up a bit of what we're doing there. All right. So yeah, let's try to now decouple some of these things too. We'll come out, we'll create a new file, call it engine.ts. We'll export type update function. That'll take a number. It'll be a void. Export type render function. All right, come on. Let me disconnect these real quick. And then this and then we can create engine options. step hertz. That'll be a number. And this will be simulation rate. We'll default it to 240. Max steps per burst. Remember that this will cap updates per tick to avoid spiral. And then use worker. This will come in later on. I've got something interesting set up. So future run sim off made. That could be kind of handy. Export class engine. We're going to have a private read-only step, private read-only max steps. And then we'll have a private on update. It'll be an update function and an on render. And then this is going to be how we kind of get faster updates. We're going to use something built into the browser called a MessageChannel. And then we'll have running. These right here need types. And then we'll have a private worker, but we won't be using that right yet. Constructor. So it'll take an on update, an on render, and ops. Engine options. So this dot on update will be our update function. On render, this dot step is equal to 1 divided by ops dot step hertz. Oh, 40. This dot max steps is equal to ops dot max. For And then this dot chan dot port 1 dot on message is equal to this dot tick update. And then we'll put some stuff in here for the future. Apps dot use worker this dot loop. And this will be future. We'll swap to this strategy. So we'll have some public controls here. So we'll have a start. If this stop running, we'll return. And then we'll set running to true. This dot last is equal to performance dot now divided by 1,000. This dot ACC is equal to 0. This dot schedule update. So we're going to be scheduling these things. Schedule render. We'll have a stop, a public stop. So if this stop running, we just return. This dot running is equal to false. And then we can cancel animation frame, and we'll be setting this up. So we'll have a private schedule update. Void this dot port dot post message. And this is going to be how we get really fast updates. So this will be the private tick update. We'll say if this dot running, we return. No point in doing that. Any of this if we aren't supposed to be running. Now is equal to performance dot now divided by 1,000 dt. We'll let dt equal mass dot min. Now minus this dot last. All right. This dot last is equal to now. This dot ACC plus equals the delta time. That's our accumulator. Let steps equals 0. And then this will, so while accumulator is greater than or equal to this dot step and steps is less than this dot max steps. This dot on update will run that. Update this dot step. So you can see that the accumulator is adding the delta times. So this will be accumulating the delta. And then we subtract this dot step, and then we increase steps. After we're done, we schedule an update. So this will immediately queue update. And then vsynced render using requestAnimationFrame. Why is it not letting me freaking write? All right, private schedule render. This dot ref ID is equal to request animation frame. This dot tick render. And then we can create the private tick render. And if this is not running, this dot on render. And we will schedule another render. We will also add public set update, and that will take an update function, and we will be able to set this at runtime. So optional update handlers at runtime. And we can get step so return a number. And then let's just document so we don't forget in the future that we want to do something with a web worker. So that would be a private boot worker function. Spin worker, exchange snapshots via message. That will come down the line. So how can we implement this into the current system? Well, one thing, I want to separate the render system so we'll say const render systems like so. And then this will be update systems. And then now we'll just be able to run this. So first things first, let's import engine /engine and type update function render function. So we'll come down to this stuff here, get rid of it. Actually, we could probably keep this. Let's keep this. We'll call that's we can get rid of this stuff and this stuff. Get that. And for this, we'll do render systems. Const update function is equal. How about we just change this to on render on update, like so. And then we have everything we need for our engine. So const engine is equal to a new engine, and it takes that there, and then we start it. All right, and we need to make sure that we've called these functions correctly. So let's go to engine here. Schedule render. And then these are engine ops. Okay. And we don't need this here. And then in our run systems, Let's do let's actually just set it to 0 by default. Okay. Let's see. Cannot read property of undefined. Did we not set running? Running is set to false. Let's try to start the server over. Undefined reading or running. Let's go to start. This dot running is true. This dot running is false. It's set to false. Wait. If this dot we may need render. Let's do this. Here we go. Right? Now let's take a look at this. What is DT? So it looks like we're not calling an update. So we'll take a look at start. Schedule update. Where is it called? Render. Schedule update. right here. We need to call that the yeah, so on message, have we not set the port? Maybe it's actually this port? Let's see. Um, let's maybe we need to start the port. Let's see, this dot chan dot port 1 dot start, and we can make that this dot chan dot port 2 dot start. All right, so after digging, it was a simple problem. Was not what I thought it was at all. In the tick render, I think is where it was. Yeah, I wasn't calling the function. I just had the name of the function there. So now we actually have it working. Very simple. Very simple. We create an engine, give it the on update, give it the on render in our step hertz. So we could put 240 in here. And it's updating really fast. We could create a we could create a component to show the frame rate. We'll call it frame rate. I don't know if we need it to be a component because we have everything we need. We just really need the system. No, we'll make it the component. And let's okay, export const frame rate, define component. So now we have a frame rate component, and in our system, create a new file called frame rate system.ts. Import type system. All right. And let's see. Or I think that's good. We'll see. I wonder, this is just me kind of riffing here. Let's see. In our render system, we can check. Uh, wait, we don't want. We'll let that happen there. For const e of world, query frame rate, render text. This is more like what I'm looking to do. Text takes a string. It doesn't take a color. Options. And then font size. Wait a second. So I think we are looking at size here. In text align is just align. And I think, is that just baseline? Baseline. And then now we can go into main. Import frame rate. And we'll come down here and create frame entity. And it should be frame rate. All right. We have values that are not moving, but they're up at the top. average. Let's come in here and change this to DTS, which should be an array. And then we'll come into here. And say FrameRate. We can actually const average. We don't have stop. Okay. Render system. Now, this is going to be we're going to get rid of this. FPS. Let's see. What is going on? So what is causing this problem here? I think it's not updating this. Let's first just manually set average to 20. Or the FPS to 20. So it is probably not in our logic here. Let's first 20. Let's see. So we're not actually updating that.
I know water can be strong on your tummy.
All right. And let's see. We're definitely getting a component. So we're getting a component. It's just our frame rate system, it's like it's not being ran. So that's probably what the case is. If we come to main, render system, update system. Name. No, wait. Yeah, we need the frame rate system. We need to import that. That's why. Guys, frame rate system. And then that goes in here. Probably just click that there. There we go. And then in our render, okay, so now we can fix the frame rate system here. Let's see. Let's just say fr dot fps is equal to there we go. So we're getting that solid 240 that we're asking for. And so I don't think we're taking size incorrectly. Align baseline size. I don't know. We'll work on that later. But we're definitely able to see the results there. I think that's a success. So we've migrated and we created the engine, and we'll actually be able to expand on this later and create a separate thread for this to run on, separate from what the rendering is on the client side. So we'll create like a service worker. But it looks like we are we're good. We could work on, I think we'll work on state management next. So let's plan for that.